October29. This is a short lecture on conics. You have passed out this particular sheet, which says you're supposed to find the equation of the circle, the ellipse, the parabola, and the hyperbola given the indicated information. And we're going to work through these problems together. We'll do the circle first. Okay, circle, endpoint of diameters, endpoints of diameter at -5, 2 over here on the left, and 3, 6 up in the upper right. Let's see how we might do that. Okay, if you look at the handout on everything you want to know about conics, but we're afraid to ask, this one here, we skip lines just for a minute and come down to circles. We know we have this second degree equation. The graphing form is where I'm going to go after, point number 2 here. So this graphing form right here. And let me go ahead and reproduce that. We have x minus h squared and y minus k squared is r squared. The pertinent information, hk is the center and r is the radius. Okay, so for our particular problem, the endpoints are given at -5, 2 and 3, 6. We know the center of the circle is the midpoint of the diameter, and you should know from pre-calculus or even elementary algebra that to find the midpoint, you average the x-coordinates. -5 plus 3 over 2 is -2 over 2, which is -1. And when you average the y-coordinates, we're looking at that and that. So 2 plus 6 over 2 is 4. So that's our center point. And those numbers immediately go in for h and k. Okay, so we have found the center. This is a relatively easy problem. We have x. Now the center says minus h, and this x-coordinate is -1. So it's minus 1, which is +1. And y minus 4 squared, we still have to figure out r squared. Well, the radius is simply this distance, so we can use the distance formula there. The radius will be the square root. You know how to find the distance between 2 points, I trust. You do a little right triangle. You find the horizontal change, that's 4, square it. You find the vertical change, that's 2, square it. And so the radius is the square root of 20. In point of fact, we really want radius squared. So radius squared is 20, and then we're done with our problem. The answer, the equation of the circle, x plus 1 squared plus y minus 4 squared is equal to 20. This is the graphing form. You might be asked to put it in the standard form, and to do that, you would just expand here. X squared plus 2x plus 1 plus y squared minus 8y plus 16 is equal to 20. And usually we rearrange this so the quadratic terms are first, x squared plus y squared, and then the linear terms plus 2x minus 8y. Move all the constants to one side, so we have 17 less 20 is minus 3 equals 0. Okay, so either one of these would be correct. You could leave it like that, or you could leave it like that. Before I go away from this problem, let me just make one other note. If I gave you this particular form of the circle and I asked where's the center and what is the radius and could you graph it? Okay, the answer is yeah, of course we can do that. We simply reverse the process that we did. We've got x squared plus 2x, I'll leave a gap, and then I've got y squared minus 8y, leave the gap. I'll move the constant term to the right side, so that's equal to 3. Okay, then we complete the square in x and in y. So completing the square in x, we know, let's see, half of 2 is 1, 1 squared is 1. And complete the square in y, we've got half of -8 is -4, squared is 16. I can't simply add 1 and 16 to this problem. I have to add 1 and 16 to both sides, plus 1 plus 16. Okay. Completing the square is a standard technique in dealing with quadratics. You'll do that a lot with conics. Okay, so now this is a perfect square. This is x plus 1 quantity squared. And this is a perfect square. This is y minus 4 quantity squared equals 20. Okay, so our center is at -1, 4. And the radius is the square root of 20. Okay. Let's see. Let's go to problem number 2. We have an ellipse. We have vertex points at -1, 1 and 5, 1. They also give us some information about the foci, which gives us some information about the focal distance, and we'll talk about that. But the question is, what is the equation of this particular ellipse? Okay, so back to everything you want to know about conic sections, but we're afraid to ask. Let's see, the ellipse information is on the back page. So again, we have a quadratic in x and y, but now the coefficients are different instead of the same. Here's the graphing form with the major axis horizontal and with the major axis vertical. Since our major axis is horizontal in this problem, major axis being the longer of the two, okay, so longer of the two is horizontal, we'll go after that second form for ellipses. So here we have x minus h squared over a squared, and then y minus k squared over b squared equals 1. And the pertinent information, hk is again the center, just like with the circle, the center. A is the length of the semi-major axis, half of the major axis. And B is the length of the semi-minor axis. And the other thing that we'll need when we work this is C, which I'm going to call the focal distance. Focal distance. And if I had to describe that, that would be the distance from the center to one of the focus points. Focal distance. Okay, so let's look at the problem and see what we know. You can look at the diagram and note that the center is at 2, 1. So we know this is 2 and this is 1. Okay, we have x minus 2 squared. We have y minus 1 squared. Okay, we still have to figure the a and the b. The a is the semi-major axis. And so if we go from the center out to one of the vertex points, you could just count and you see a in this problem is going to be 3. So 3 squared is 9. Don't know b squared. Okay, so if we look at the diagram, it's very difficult to tell the length of the semi-minor axis. It's a little bit more than 2, but we don't know exactly. So we have a nice formula that ties together a, b, and c. A squared minus b squared equals c squared. Sort of similar to the quadratic formula, except there's a minus instead of a plus. Okay, so let's put in what we know. We know a squared is 9. We don't know b squared. C squared, that's the focal distance. So again, look at the diagram. The center is at 2, 1. One focus is at 4, 1. The other one is at 0, 1. The focal distance is 2. So we square that, and that allows us to solve for b squared. So 9 minus 4 is b squared. B squared is 5, and that would go right there. Okay, so the answer to this problem, we have x minus 2 quantity squared over 9, and we have y minus 1 quantity squared over 5 is equal to 1. You can leave it like this, or if you want, you can put it back in general form, just like we did with the circles. I'd probably multiply through by 45, the least common denominator, and get 5 times x minus 2 squared plus 9 times y minus 1 squared is equal to 45. And again, usually we would expand this. X squared minus 4x plus 4, 9 times y squared minus 2y plus 1 is equal to 45. Again, just expanding, we have 5x squares minus 20x's plus 20 plus 9y squares minus 18y's plus 9 is 45. And lastly, getting the quadratic terms first, 5x squares plus 9y squares, then the linear terms minus 20x minus 18y, and then the constant, so we've got 29. 29 is equal to 45, so we should probably go ahead and move the 45 across. And what do I get? 16? Okay, negative. So it looks like we have 5x squared plus 9y squared minus 20x minus 18y minus 16 is equal to 0. So this would be the general form of our ellipse. And again, I can sort of ask the same question I did with the circles. Suppose I gave you that. Could you get it into the graphing form? The answer is yes. We're going to complete the square, and this is how it would go. We would first isolate the x terms, 5x squared minus 20x, leave a gap. Then we put the y terms, so plus 9y squared minus 18y, leave a gap, and then throw the constant to the other side, so that would be 16. Okay? Now, to complete the square appropriately, we should first factor these. I'll take the 5 out, leave the x squared minus 4x, leave a gap. On the y's, I'll take out the 9. I'll leave y squared minus 2y, leave the gap. And I still have equals 16. Okay? Now, let's complete the square. For the x's, you would take half of negative 4, which is negative 2. You square it, and you get plus 4. For the y's, you would take half of negative 2, which is negative 1, square it, and you get plus 1. You can't go changing the equation. You have to keep it balanced. So look what we did on the left side. We put 5 times 4, so we have to add 20. And we put 9 times 1, so we have to add 9. Okay? Because this was in the parentheses, it did have to be multiplied by 5. Same thing here. This was in the parentheses. Okay, cleaning up, 5 times x minus 2 squared, x minus 2 quantity squared, 9 times y minus 1 quantity squared, it's 45. And lastly, we'll go ahead and divide everything by 45. So divide that by 45, you get a 9 in the bottom, divide that by 45, you get a 5 on the bottom, divide that by 45, and you get a 1. And sure enough, here we are, x minus 2 squared over 9, y minus 1 squared over 5 equals 1. Okay, I'm going to stop this video here. I'll do another one for the parabolas and the hyperbolas on the bottom of